Welcome to Catalyst MedHub, where we ignite understanding and make learning easier. In our today's class, we'll be discussing integration by parts under integration. Integration by parts is a calculus technique or is an integral technique that allows us to find the integral of two functions multiplying each other, just like the product rule of differentiation. And the formula that we'll be using while solving integration by part is the integral of u dv will be equals to uv minus the integral of v du. This is the formula that we'll be using to solve any question under integration by parts. It is called integration by part because you will integrate one part and you will differentiate the other part. Now, how will you know the part that you will integrate and how will you know the part that you will differentiate? It all comes from the question. Any part you take as your u, you will differentiate it to get du. And any part you take as your dv, you will integrate it to get v. Now, there are order of priority of the function that we must know that will allow us to understand the integration by part very well. L-I-A-T-E. This is the order of their priority. The L here stands for log function. The I is inverse trig function. Whereby the A is an algebraic function, the T is trig function, and the E is exponential function. So, if you are having two different types of a function, you will use these acronyms to know which one will be your u and which function will be your dv. So from the formula u dv, you have a question, look at these acronyms and know the one that comes first from this acronym is the one you will take as your u, whereby the function that comes last will be your dv. For example, if you are having algebraic function together with an exponential function, the algebraic function will be your u, whereby the exponential function will be the dv. If you are having log function with an algebraic function, the log function will be u, whereby the algebraic function will be the dv. Now let's solve question on the integration by parts. This question states that integrate the integral of x sin x dx. We say that if you are having more than one function or if you are having two functions multiplying each other, the best method you can use to find their integral is the integration by parts. So from this question, we are having x sin x. We are having two different functions here. X here is our algebraic function and sin x is our trigonometric function. Now, which one do we take as our u and which one do we take as our dv? From here, we can see that the algebraic function comes first before the trigonometric function. So our u here will be our x and our dv will be sin x. So we'll now be using this. The formula is integral of will be our sin x. We said our u, so therefore our u is now equals to x. And our dv is now equals to sin x dx. So from here, we say that anyone that you take as your u, you will differentiate that one to get du. And anyone you take as your dv, you will integrate that one to get v. That is the reason why it is called integration by part. Differentiate one part and integrate the other part. So differentiating u to respect to x, we'll be having du dx will now be equals to, if you differentiate x, we'll get 1. Now integrating dv equals to sine x dx. If you integrate dv, you have v, which will now be equals to, if you integrate sine x, we'll be having minus cos x. The integral of sine x is minus cos x, whereby the integral of cos x is sine x. So now we've gotten almost all the parameters we are needing in the formula. We'll just substitute them back to the formula. We'll now be having the integral of x sine x dx will now be equals to, our u is x multiplied by our v is minus cos x, then minus the integral of v. Our v is minus cos x, then multiply by du, and our du here, okay, from here you make your du subject to the formula by cross multiplying. If we cross multiply, our du will be equals to dx, because we are having du over dx equals to 1. Du will now become dx, because dx multiplied by 1 will still give us dx. So our du from here is now dx. So from here will now be equals to x minus cos x. We'll be having minus x cos x. Then minus, we can factor out this minus. So now you're having minus and minus will now become plus. Then the integral of cos x dx. From here, we'll be having minus x cos x plus the integral of cos x dx will give us sine x. So we'll be having plus sine x plus c. So this is the integral of x sine x dx, which is minus x cos x plus sine x plus c. So the next question is integrate x exponential x dx. We are having two functions here. We are having algebraic function and we are having the exponential function. So from here, our algebraic function also comes before exponential function. So our u will be x and our dv will be exponential x. So for us to get our du, we will differentiate u, and for us to get v, we will integrate dv. Integrate, okay. Differentiating u to respect to x, we'll be having du dx will now be equals to, if you differentiate x, we'll get 1. Then we'll make our du subject to the formula, which will now be du will now be equals to x. Now for the dv part, we'll integrate both sides. If you integrate dv, you have v, which will now be equals to, if you integrate exponential x, you will still be having exponential x. So it's still the same thing as exponential x. We've gotten all the parameters needed to be substituted into the formula. Then we'll now substitute it back to the formula. That is, our integral of x exponential x dx will now be equals to our u, which is x, multiplied by our v, which is exponential x, then minus the integral of our v, which is exponential x multiplied by du, and our du is dx. So from here, x multiplied by exponential x will be having x exponential x, then minus the integral of exponential x is still the same thing as exponential x plus c. So that is the integral of x exponential x dx using integration by part. The next question is the integral of x squared exponential x dx. Our u from here is our x squared and dv is exponential x dx. So we will differentiate u to respect to x and we will integrate dv in respect to exponential x dx. Differentiating u to respect to x, we will be having du over dx, which will now be equal to, if you differentiate x squared, you will be having 2x. Then making our du subject to the formula, our du will now be equals to 2x dx. From there, we'll integrate the v. If you integrate the v, you get v, which will now be equals to, if you integrate exponential x dx, you still be having exponential x. Then we've gotten our u, we've gotten v, we've gotten du. Substituting it back to our integration by parts formula, which is the integral of x squared exponential x dx will now be equals to our u, and our u is x squared multiplied by the v, which is exponential x, minus the integral of v, and our v is exponential x multiplied by du, and our du is 2x dx. We'll be having x squared exponential x minus the integral of exponential x 2x dx. Again, we have to integrate this part again using integration by part, because we have to integrate all these parts here, and since we are still having two different functions, you integrate it again by parts. Now we will now be having the integral of exponential x 2x dx. Here our u is 2x and our dv is exponential x. Our du dx will now be equals to 2. Then making du subject for the formula, it will now be equals to du will now be equals to 2 dx. Then integrating both sides here, if you integrate the v, you'll be having v, which will now be equals to, if you integrate exponential x, we'll still be having exponential x. So from here, we will substitute it into our formula. Therefore, the integral of exponential x 2x dx will now be equals to u, and our u is 2x multiplied by v, which is exponential x, minus the integral of v du, and our v is exponential x, and our du is 2 dx. So from here we will continue. We will now be having 2x exponential x minus the 2 is constant here. We can factor out 2. So we will now be having 2 integral of exponential x. So from here, if you integrate exponential x, you still be having exponential x. So the integral will now be 2x exponential x minus 2 exponential x. This is the integral of exponential x 2x dx. Then we'll come and substitute it here. So coming here now, we'll be having x squared exponential x minus the integral of exponential x 2x dx, which is 2x exponential x minus 2 exponential x. So we'll be having 2x exponential x minus 2 exponential x plus c, which is our constant. This is how you can solve question under integration by parts. Kindly subscribe, like, comment and share. Don't forget to turn on your notification bell so that you don't miss any new video.